Good day, my dear grade 9 STE students. Welcome to this video lesson. In this video, we will discuss precipitation reaction. And you are expected that at the end of this video, you must be able to, number 1, predict if precipitation reaction will occur or not. Number 2, write molecular equation, Ionic equation, and net Ionic equation. And number 3, identify spectator ions. And before we proceed, I want you to recall the solubility of some substances, of some ionic substances in water. I have 5 substances. I want you to predict if it is soluble or not in water. Okay, let us have our first compound. Our first compound is calcium phosphate. Is it soluble or insoluble in water? What is your answer? Okay, the answer, class, is insoluble. Next, we have manganese hydroxide. What do you think? Is it soluble or insoluble in water? What is your answer? And the answer, class, is insoluble. And the third substance, we have silver chlorate. What do you think? Is it soluble or insoluble in water? If your answer, class, is soluble, then you are right. Very good. And we have the fourth compound. We have potassium sulfite. What do you think? Okay, yes, if your answer is soluble, then you are correct. Then the last one, we have calcium carbonate. Is it soluble or insoluble in water? What is your answer? The answer, class, is insoluble in water. Do you get the correct answer, my dear students? Very good. Nice job. Okay, now class, I want you to recall the solubility rules for common ionic compounds in water that can also be used in our next lesson. So for soluble compounds in water, those includes alkali metals, including ammonium ion, also compounds containing acetate ions, nitrate ions, cyanide ions, hypochlorite, we have chlorite, chlorate, and perchlorate ions. Also compounds containing halides are also soluble like chloride, bromide, iodide, except if they are paired with silver, mercury, and lead-2 ions. Compounds containing fluoride ions are also soluble in water except if they are paired with magnesium, calcium, strontium, barium, and lead-2 ions. Compounds containing sulfates are also soluble in water except if they are paired with calcium, strontium, barium, silver, mercury, lead-2 ions. And these are the compounds that are insoluble in water. Compounds containing carbonates, phosphate, chromate are insoluble in water except if they are paired with alkali metal ions and ammonium ions. Also, compounds containing sulfide ions are insoluble in water, but it becomes soluble if they are paired with alkali metal ions, ammonium ion, barium, calcium, and strontium ions. Also, compounds containing hydroxide ions are insoluble in water, but they are soluble if they are paired with alkali metals and ammonium ion, including barium, calcium, strontium ions. Okay, hope you are now reminded of the solubility rules because that will be used in our next lesson. Okay, now I have here a simple experiment. I want you to observe what will happen if I will combine these two substances. Okay, these are the two substances. Let us see what will happen if I will mix these two substances. Okay, let us allow this one to settle for a few minutes. And let's try to observe. Okay, now let us observe what happens to our experiment. Okay, this is now the result of our experiment. Notice that we already have white substance present in here. What do you call this white substance that is being produced in this reaction? You're right. This is what we call precipitate. Precipitate is a substance that is being produced in precipitation reaction. In other words, this is an example of what kind of reaction? Precipitation reaction. Okay, so what is precipitation reaction? Precipitation reaction occurs when there is a formation of insoluble product or precipitate. Precipitation reactions usually involve ionic compounds. What is then a precipitate? A precipitate is an insoluble solid that separates from the solution. So an example is we have here a yellow precipitate, or in our previous activity, you saw a white precipitate. I have your class an example reaction. When an aqueous solution of lead to nitrate, which has this formula, is added to an aqueous solution of potassium iodide, a yellow precipitate of lead to iodide is formed. As you can see in this picture, we combine two colorless solutions of lead to nitrate and potassium iodide. So combining these two will produce a yellow precipitate. And how do we know that there is a precipitate? That is because in the solubility rules, lead to iodide is insoluble in water. Because of the formation of this precipitate, we can say that this one is an example of precipitation reaction. Okay, when does precipitation reaction occur? Precipitation reaction occur when pairs of oppositely charged ions attract each other so strongly that they form an insoluble ionic solid. So this is already what we call the precipitate, this one. Meaning, once there is a precipitate that is being formed, then we can say that precipitation reaction will occur. So precipitate is again an insoluble ionic solid which we can determine using our solubility rules. Okay, so this is class an example of precipitation reaction simply because of the formation of precipitate. So before that, so I want you to be reminded that our reactants here, we have lead to nitrate and we have potassium iodide, and both are soluble in water because of the subscript, or you can check using our solubility rules. So meaning as we combine these two substances, although they are both soluble in water, they will form two substances, and these are lead to iodide and potassium nitrate. So based also from our solubility rules, potassium nitrate is soluble in water. That is why we have AQ as our subscript. Whereas lead to iodide is insoluble in water. That is why we write S. Or you can simply draw arrow downward to indicate that this is a precipitate or insoluble substance. So why is this? Why is it that this is precipitation reaction? Simply because one of the products is an insoluble substance or it produces what we call precipitate. Okay, do you understand? Okay, very good. Okay, next. Okay, let's try another example. So we have here our reactants, sodium hydroxide and potassium chloride. Both are also soluble in water. When they undergo double displacement reaction, we produce sodium chloride and potassium hydroxide. If we will check using our solubility rules, both sodium chloride and potassium hydroxide are soluble in water because of the presence of alkali metal ions. And so, once we do not have insoluble substance in the product side or no production of insoluble substance, then we can say that this one has no precipitation reaction. Has no reaction. Okay? Are you following? Okay, very good. Okay, next, let us proceed to how to write a molecular equation, ionic equation, and net ionic equation. Let us first differentiate the three equations. Okay, for molecular equation, it is an equation that shows complete chemical formulas of reactants and products. It shows the reaction of molecules where all species are present, which exist as whole unit or molecules. So we have here an example. Again, our example before, we have lead to nitrate, potassium iodide producing lead to iodide and potassium nitrate. As you can see, we have here chemical formulas and it exists as a whole unit. That is molecular equation. What about ionic equation? Ionic equation is a kind of equation which shows what happens to the substances in solution. It shows dissolved species as free ions. So again, for a ionic equation, it shows what happens to the substance in solution. So which means if a substance is soluble in water, you have to ionize the substance. If it is insoluble, it will retain as a whole unit. Like for example, lead to nitrate, since they are both soluble, we ionize lead nitrate and to lead 2 and NO3. And potassium iodide is also soluble, so we also ionize N2 potassium ion and iodide ion. Whereas lead 2 iodide is insoluble in water, so it will remain as a whole unit. While potassium nitrate, since soluble in water, it will also be ionized into potassium ion and nitrate ion. So this is class an example of ionic equation. Do you understand? And next, we have the net ionic equation. Net ionic equation is an equation that shows only the species that take part in the reaction. It is the species left after spectator ions are being cancelled out or eliminated. So in other words, these are only the the species that take part in the reaction. As we can see, based from the Ionic equation a while ago, there are ions that are produced or that are ionized both in the reactant side and in the product side, just like nitrate ion we have here, this one, and the other one. So we have to cancel this out. Another is potassium ion is also present in both the reactants and in the product side. So we call them as spectator ions. So what will remain will be lead 2, this one, which we write in here. We also have the iodide ion, which we also write in here, and the lead 2 iodide. So that means that the net ionic equation are this one only. This is only the reaction between lead 2 plus the iodide, the ion, forming lead 2 iodide because we eliminated the spectator ions. Okay? I hope you understand, my dear students. Okay, let's define spectator ions. Spectator ions are ions that are not included in the overall reaction. Not included because we cancel them before we write our net ionic equation or our overall reaction. So we call them as spectator ions. Again, spectator ions are those ions that are present both in the reactant side and in the product side. Okay, in this reaction, our spectator ions are nitrate ion and potassium ion. Do you understand? Very good. Okay, this time class, we have a sample problem. So in here, you are going to predict what happens when potassium phosphate solution is mixed with calcium nitrate solution. And we are asked also to write the net ionic equation for this reaction. Let's check first if there is a precipitation reaction. Okay, we have here step number 1. We have to write the balance equation of the reaction. So let's check later on if there is a formation of precipitate. So going back to our knowledge in double displacement reaction, since we have here two compounds of potassium phosphate and calcium nitrate, when we combine this one, we have to combine the positive of the first substance with the negative one. And then the positive of the second compound is paired with the negative of the first compound. So combining potassium and nitrate, we produce potassium nitrate. Combining calcium and phosphate, we produce calcium phosphate. I know you know how to write the subscript. Okay, so checking the solubility rules, calcium phosphate. So for phosphate, compounds containing phosphate are insoluble except if they are paired with alkali metal. Since calcium is not an alkali metal nor ammonium, therefore, this is insoluble in water. So we write here S. And potassium nitrate, since it is a nitrate soluble in water, so we write AQ. So in writing for the molecular compound or molecular equation, by the way, you always balance the equation. So we balance the equation by writing 2 in the potassium phosphate, 3 in calcium, and 6 in potassium nitrate. I know you already mastered out how to write chemical formulas and balancing chemical equation. And so therefore, this is an example of precipitation reaction because of the formation of solid precipitate. Okay, next is step number 2. We have to write the ionic equation by writing the soluble substances in ionized form. So based from our molecular equation written a while ago, so we need to ionize the substances that are soluble in water. So potassium phosphate is soluble in water. So what are the ions? So it is being separated into two ions. We have potassium ion. So we have 6 because we multiply 2 times 3. We have 6 potassium ion and we write AQ since it is being ionized in water. And the other ions is PO4 negative 3 or 3 negative. That is because of this. You know already this one. This is the ion. We have 2 because of our coefficient. It is also AQ since it is being ionized in water. And then the other one is calcium nitrate. Since it is also soluble in water, we have to ionize. So Ca plus 2 because of this. I know you can still recall the crisscross process in writing chemical formula, meaning to say calcium has an oxidation number of positive 2 and we have 3 of this because of the coefficient 3. And the other one, we have nitrate, a negative 1 since we do not have here any subscript. And we have how many nitrates? 2 times 3, we have 6 nitrate ions. And we also added AQ. And for calcium phosphate, since this is insoluble in water, so we do not need to ionize the compound. And we proceed to, we always write plus, again, my dear students. Potassium nitrate, since this is soluble in water, we have to ionize this one and 2 potassium ion, K plus. Since we do not have any subscript, meaning to say K plus, or you can check your periodic table for the oxidation number if you are not sure or familiar with just looking at the chemical formula. We have 6 of this. And for nitrate, we have also 6 because of this coefficient. Okay, so far, this is the ionic equation. So all are ionized except for the insoluble substance, which is our calcium phosphate. And then for step number 3, cancel all the spectator ions and write the net ionic equation. So based from our previous ionic equation, we need to look at the ionic equation to find out if there are ions that are present both in the reactant side and in the product side. Let's check. So we have here 6 potassium ion. Also, we have here 6 potassium ion, and then we have 6 nitrate ion and 6 nitrate ion. So we cancel this out. And so our net ionic equation will be calcium plus 2. We have 3. So we started with the positive, my dear students. And then 2 phosphate ions forming this one, calcium phosphate, which is solid. So therefore, this is our net ionic equation. So what are our, by the way, what are our spectator ions? Our spectator ions, we have potassium ion and nitrate ion. Now, to check if the net ionic equation is balanced charges, a number of atoms, we have to check 3 calcium. We also have 3 calcium. 2 phosphate ion. We also have here 2 phosphate ion because of the subscript. And for the charges, 3 times 2, we have positive 6. 3 times 2, we have negative 6 because of this negative charge, which is equal to 0. And it just the same or equal to the charge of calcium phosphate. Since this is a compound, it should have a zero charge. Okay? Do you understand? Do you know already how to write the molecular equation, the Ionic equation, and net Ionic equation, or even how to identify the spectator ions? Okay, let us have an additional example. We have here determine the net Ionic equation of the reaction between silver nitrate and sodium chloride. So we need to predict, before we write, by the way, the molecular equation, you need to predict if precipitation reaction is possible or not. If not, there is no need for you to write the molecular equation, the Ionic equation, and net Ionic equation. So let's combine now silver nitrate. Just sorry for my writings. So we have silver nitrate plus sodium chloride. So these are our reactants. So before we predict the possible products, let us try first to identify if this is soluble or not in water using the solubility rule. So since we have here nitrate ion, so this is soluble in water. So I will write the subscript AQ. In the same manner, sodium chloride is also soluble because of the alkali metal sodium. So also AQ. So in the double displacement reaction, as I have told you a while ago, the positive of the first compound, the positive ion, will be paired with the negative ion, forming silver chloride. Silver has an oxidation of positive 1. Chlorine also has a negative 1, so we have this one as our formula. Positive 1, negative 1. Positive 1, negative 1. So we do not have any subscript. Okay, we can just erase. I know you are already well versed of that. And then sodium will be paired with nitrate. So just write plus. Sodium will be written first because it is the positive ion. And nitrate. And O3. So also they have positive 1 charges for sodium and negative 1 for nitrate ions, so we do not have any subscript. And then to check whether they are soluble or not in water, silver chloride, since we have our silver paired with chloride or chlorine, this is insoluble in water. So we write S. And for sodium nitrate, they are all soluble because sodium is alkali, nitrate is also soluble in water, so we write AQ. So far, if you will check our equation, we already have our products and the equation is already balanced. So this is already the molecular equation between the reaction of silver nitrate and sodium chloride. So let's now write the Ionic equation. So for Ionic equation, again, we have to ionize the substances that are soluble in water. So here we have to ionize silver and nitrate. Silver nitrate is being ionized, and to silver ion, silver has a charge of positive 1. So lagyan natin ng AQ. It's difficult to write, my dear. Then plus the nitrate ion. We only have 1 nitrate ion. So the charge is negative. Again, we write the AQ. Okay, sorry for the penmanship. Then sodium chloride is again soluble, so we ionize sodium chloride. Okay, Na, oh my God, positive, AQ. Then chlorine also ionized in water, So we have AQ. So we only have 1 ions each. And then we simply write the formula silver chloride since it is insoluble in water. So you just have silver chloride. S. And just ionize also sodium nitrate. Sodium is positive 1 or simply plus. Then AQ. AQ yan, my dear students. And then the other one is NO3 negative. This is also AQ. Okay, so far this is our ionic equation. We ionize silver nitrate into silver ion and nitrate ion. Both have only 1 ions. Sodium chloride also are being ionized into sodium ion and chlorine ion. Both are also in 1 ion each. And then silver nitrate, since this is insoluble in water, you need not ionize the compound. And then sodium nitrate are also being ionized into sodium ion and nitrate ion. Also has only 1 ion each. And do not forget to write AQ if they are being ionized in water. So far, this is our ionic equation. And let's try now to write the net ionic equation. Now, in writing for the net ionic equation, we have to cancel out the spectator ions. Again, spectator ions are both present in the reactant side and in the product side. So let's see silver if we have in the product side. So wala. NO3. So we have to cancel this out. Same this one. Sodium also has in the product side. While chlorine, we do not have. So far, we remove or we cancel out or we eliminated nitrate and sodium ion. Therefore, our net ionic equation will be, we have silver positive, we have AQ plus, we have start with the positive, plus Cl negative, also AQ, and producing this one, silver chloride. This is solid. So far, this is class our net ionic equation. Naintindihan, my dear students? Do you understand? Okay, very good. And by the way, what are our spectator ions in here? So we have nitrate ion and sodium ion. These are our spectator ions. Okay, one more example. Okay, I have one more example. So we already have here the reactants. We have ammonium carbonate and calcium chloride. So mayroon na tayong subscript AQ. So meaning they are both soluble in water. So we need to predict if precipitation reaction will be formed. So let's combine ammonium with chlorine. So ammonium ion NH4 negative positive 1, and chlorine has also a charge of negative 1. Therefore, we have this one as our product. Then we produce another compound, calcium plus carbonate. So calcium has a charge of positive 2 or 2 plus. Carbonate has also positive 2. Positive 2, negative 2. So again, since we have the same oxidation number, we have to remove that one, meaning they are 1:1 ratio because they have the same oxidation number. So our formula will be CaCO3. Okay? I hope you still recall our chemical formula writing. So this one, negative 1, positive 1. So that's our chemical formula. That's our molecular equation. So our problem now is to balance since we cannot write the ionic equation without balancing the molecular equation. So in the reactant side, we have here 2 ammonium ion. So meaning we have to write here 2. to balance. And then carbonate, we only have one, so no problem. But chlorine has two, so it balances because chlorine has a coefficient of 2. Therefore, we already have a balance equation. Okay? Again, ammonium has two ions or two molecules. That is why we have right here 2, meaning we have already ammonium 2. Carbonate, we only have one, so we have here 1 carbonate. Calcium, we have here 1 calcium. Chlorine, we have 2, so we have here 1 times 2 here, so we have 2 chlorine ions. To check if one of the products is soluble or insoluble in water, we need to look again with our solubility rules. In ammonium chloride, since ammonium is always soluble, therefore this is soluble in water. We have to write AQ. And calcium carbonate, I know you can recall this one a while ago. This one is insoluble in water. So therefore, precipitation reaction is possible. Okay, so we already have the molecular equation. Let's have the ionic equation. Okay, so let's ionize the one that are soluble in water. So this one is soluble, so we will ionize. How many ammonium ion do we have? So ammonium ion has NH4, negative, no, positive. Positive one or just simply positive, and we have subscript of 2, meaning we have 2 ions of ammonium. Then, do not forget to write the AQ. Okay. Then plus the carbonate ion, CO3. Meron tayong subscript na 2 here, meaning carbonate has negative 2 charge. Negative 2 yan. Okay, then we also do not forget to write the EQ. Then plus calcium chloride, again, is soluble in water. So we have to ionize calcium, positive 2 or 2 plus because of the subscript 2. We only have 1. And then plus chlorine ion. We have here subscript of 2, meaning mayroon tayong 2 chlorine ions. Negative, and then AQ. And then forming, so let's write the products below. For ammonium chloride, you just need to, we need to write 2 ammonium ions because of the coefficient. NH4, positive. Then this is also AQ. And then chlorine. We have 2 chlorine because we have here coefficient of 2. Negative. Then AQ. Plus the calcium carbonate. This is plus calcium carbonate. By the way, this is S because this is insoluble in water. So S. Okay, so far we already have the ionic equation of the reaction between ammonium carbonate and calcium chloride. So let's now try to write the net ionic equation by canceling all the spectator ions. Let's check if this is an spectator ion. So do we have the same in the product side? Yes. We have carbonate, wala. Calcium, no. We do not have any calcium in the product side, but we have chlorine ion. Okay, I should have 2 here. Am I right? This is supposed to have 2. Same here. Okay, canceling ammonium ion and chloride ion. The net ionic equation will be, so we will start with the calcium since this is positive. So calcium, positive 2 or 2 plus. This is AQ. plus the carbonate, CO3 negative 2 or 2 negative is also AQ plus I naught plus equal to the calcium carbonate. Okay, so for this is now our net ionic equation. If you will check the charges, this is just equal to 0. Positive 2, negative 2, 0, and equal to 0 for calcium carbonate. And then, again, what are our spectator ions? Our spectator ions, we have ammonium ion and chloride ions. Okay? Do you have any reactions? Do you have any questions with regards how to write molecular equation, ionic equation, and net ionic equation? Feel free to ask questions. You can text me whatsoever. Okay, and to summarize our learnings, we have here precipitation reaction occurs when two aqueous solution react forming a precipitate. Take note, there is a formation of an insoluble substance which is called the precipitate. A molecular equation contains all the chemical formulas of the reactants and products and always be balanced. Okay, we always need to balance our molecular equation. And then a ionic equation shows what happens to the substance when dissolved in water, meaning you need to write in ionized form those compounds that are soluble in water and in molecule or in a formula unit if it is insoluble in water. For the net ionic equation, it only shows the species that take part in the reaction, while the spectator ions are the ions that are cancelled out and do not take part in the net ionic equation, meaning it is being present both in the reactant side and in the product side. And now let us have some precipitation reaction examples in real life. Precipitation in water pipes. I know you observe this one at home. So hard water consists of many impurities like magnesium and calcium oxides and are generally found in water pipes as precipitate. That is why there are cases that our pipes are not anymore, the water are not anymore flowing. That is because of this precipitate. Or you can also have, when you are boiling hard water, there are also precipitate that was formed after boiling. Have you noticed that? I hope you noticed that one. Another example is the formation of kidney stone. This is because of the reaction of calcium ion and oxalic acid. So this is the reaction between calcium ion and oxalic acid that are present in food result in calcium oxalate, which is a type of kidney stone. So, meaning we have to avoid food that are rich in oxalic acid. So, one of the substances that are rich in oxalic acid is spinach. Also, I think beans, yung mga tofu. So, they are rich in oxalic acid. So, you need to use them minimally or eat them minimally. Another example, practical uses of precipitation reaction, we have wastewater treatment. A chemical is added to wastewater so that the pollutants and impurities, like lead, precipitate out from the water, which is then sent for further purification. So, meaning a chemical is being added so that a precipitate is being produced and it is being removed from the water before it is further purified. Another is metallurgy. Oxalic acid is mixed with seawater and brine water to extract calcium and magnesium, both of which are precipitates or form precipitates. Okay, so those are the practical application or application in real life of precipitation reaction. I hope you learned something from those applications. And now, I hope you are ready with our short assessment. I want you to prepare just one whole sheet of paper. Okay, and for your short assessment, I have here two group of reactants. What you need to do is to predict if a precipitation reaction will occur or not. And if possible, you write the molecular equation, the ionic equation, and net ionic equation, and also identify the spectator ions. I want you to answer this one for 5 minutes. You can stop the video while you are answering. Okay, class, you can start now. Are you now done, my dear students? So this is now our answers case. So I want you to check your own paper. If you are checked from molecular down to spectator ions, you can give 5 points. Okay, for number 1, the molecular equation, we have barium nitrate plus potassium sulfate will result in barium sulfate and potassium nitrate. So to balance, we need to write here 2 that balances potassium in the product, in the reactant side, and nitrate in the reactant side. And for the ionic equation, we have to ionize barium nitrate to barium ion and nitrate ion. So we have here 2 ions of nitrate, and potassium sulfate is also being ionized, forming potassium ion. We have 2 ions, and sulfate, we only have 1 ion. And barium sulfate is in formula unit form, and potassium nitrate is being ionized, forming 2 potassium ion and 2 nitrate ion. Then canceling our spectator ions, we have NO3 or nitrate ion and potassium ion. So after canceling those spectator ions, the net ionic equation will be barium positive 2 and sulfate negative 2, forming barium sulfate. And our spectator ions are potassium and nitrate. So if you are checked, you give 5 points. Then number 2, we have reaction of iron nitrate and potassium hydroxide, and it will form iron hydroxide and potassium nitrate. So potassium nitrate is soluble because of the nitrate ion and potassium ion, while iron hydroxide will be insoluble. To balance the equation, so we have here 2 ions of nitrate. That is why we added coefficient of 2 before potassium nitrate, and that makes our potassium 2. So to balance, we need to write 2 in the reactant side before potassium hydroxide, and that makes our hydroxide 2 ions, and that balances our hydroxide in the product side. And so far, this is our balanced molecular equation. And to ionize or to write the ionic equation, we have to ionize iron nitrate. So this is the iron positive 2, 1 ion, and we have here subscript up to that. Is why we have 2 ions of nitrate, and we also have 2 ions of potassium and 2 ions of hydroxide. And then it is being written in the formula unit for iron hydroxide because this is insoluble in water. Potassium nitrate is being ionized into potassium ion 2 and nitrate ion. We also have 2 because of the coefficient 2. Then we have to cancel out the spectator ions. We have nitrate here and potassium. And the net ionic equation will be iron positive 2 hydroxide, 2 hydroxide ion, and will form iron 2 hydroxide. So for our spectator ions, we have potassium and nitrate. Are you perfect? Very good. Can pass your assessment anytime tomorrow. And for your assignment, I want you to identify 2 aqueous solution that you can combine where precipitation reaction is possible, and you have to show the molecular equation, ionic equation, and net ionic equation. And also you include what are the spectator ions. That's all, my dear students. Thank you so much, my dear students, for watching this video lesson. I hope you'll learn something new from this video episode. See you again on my next video lesson. Okay, bye-bye.